Good afternoon, all. I think we are at a very, very disadvantage here because the previous session already covered most of the things that we wanted to cover as part of our session, but we'll try to keep it interesting in a different way. Now, now we have seen that the previous session talked about what a software, supply chain can do, right? But let's go a little previous to that. Why did, first of all, the supply chain came into picture? Now with this internet, we have seen that everything is interconnected, right? Anywhere, any part of a system, any issues will cause a trouble in any other part of the world. Similarly, information flows from one part of the world to another part of the world in a fraction of seconds without any boundaries, right? How was this possible? With internet, with a lot of free softwares available or open source softwares available, people were able to build whatever they want, right? Their imagination was the only limitation. With it, we created a very big ecosystem where anybody could use this and build whatever they want. But with the advantages, we always know, right? There's always another disadvantages, like a two sides of a coin. Now, any issue with any one part of the component will cause an issue in the whole system. And this is what is a software or supply chain risk that the previous session was talking about. Now, Log4j is one such issue that we have seen it in recent past. Why did it create such a big issue? Now, we'll dwell a little bit more on this from my session panelists in understanding what open source is, what is the zero-day vulnerability, and how at an organization level we can address this. Okay. Now, my first question is to Mr. Lokesh. What exactly is an open source software and why is it that companies use it? What's the advantage with that? What do you look?
Good afternoon, everyone. Thanks, Sunil, for the brief introduction. I think if you look at the world, how things are evolving, everything is getting software defined, right? Whether you talk about your storage, your network, for that matter, your entire data center, everything is getting software defined. This also means that there is going to be a good composition of various types of software. Homegrown, also known as proprietary code, as well as third-party code. When you talk about this set of softwares, especially the third-party code, right, you will have two key components. One is the open source or the free open source software, and the other one is the commercial or off-the-shelf softwares, right? The focus of this discussion is to look at why it is important to look into the free and open source software, what type of risk it's going to cause. At a high level, it makes us important to distinguish between the closed software and the open source software because of the very nature of how it gets contributed, how it gets created, and how it gets managed. The entire life cycle of the open source software makes it clearly unique from the closed source software. Also, from a developer standpoint, if you look at it, right, this entire paradigm of open source software brings in a lot of new advantages. Whether it is about flexibility, whether it is about transparency in the code, or whether even the perceived security, because the code is available in the public and anybody and everybody can audit it, right? And also if you look at from other angles, we also have the advantage of no vendor lock-in, because you will be able to use the code as and when you want and as many projects as you want. Also, if you look at the other paradigms that are happening, right, each of the development teams can really get started much quickly, and this aligns very much with the agile model of development or the scaled agile model of development, which is quite popular among all this. Having said all these things, there are also other dimensions of risk which we're going to cover in a little while, but the key message we need to importantly remember here is the development of an open source software is so distributed, which also means that we have a lot of risks that are associated with that. So with that, I'll take a pause here so that we'll cover the other important risk elements as we progress further.
Thanks, Lokesh, for the brief intro on what open source software is and what risk comes with that. Let me point my next question to Ms. Dhanalakshmi to understand what on zero-day vulnerability is. We've been hearing a lot of zero-day vulnerabilities day in and day out. what exactly is a zero-day vulnerability and how is it different from other vulnerabilities?
Hey everyone, am I audible? Yeah. So basically in the security industry, we are hearing multiple fussing terms like zero-day vulnerabilities, one-day vulnerabilities, and well-known vulnerabilities. What is this zero-day vulnerabilities? Basically, threat actors and attackers usually scans for code flows and checks for security sags in the softwares and systems which is widely used, which can be either open source or it can be a like well-known softwares. So they discover the vulnerabilities which is not known to the software developer or software builder and system vendors. That is called zero-day vulnerabilities. On the other hand, whereas the other vulnerabilities which can be already discovered by the security researchers and it is noticed to the organizations which is developing those software or systems wherein they might have already implemented patches and workaround for those vulnerabilities. But in case of zero-day vulnerabilities, because of this anonymity of nature of the zero-day vulnerability, no patches won't be available from the vendor. It creates a larger attack surface, also like within better success rate of exploitation. That is what happened in Log4j as well.
Thank you, Ms. Dhanalakshmi. So to put it in perspective, that means any vulnerabilities may start with zero day, but then it will follow the life cycle of any other vulnerability. So thanks for that. My next question is Mr. Gupta. To understand what are softwares, what is the supply chain risk that we're talking about, and is it only limited to IT industry?
Good afternoon all. Before I start, I have a small disclosure. Whatever I express here are purely my personal opinions and nothing to do with my current or previous employers. Typical risk management, right? Right. See, global supply chain, it's basically, if you need to understand, step back. In a flat world, global supply chain is the only thing that is thriving the business. It's one of the most important and critical factor for a business to sustain. Whether it is the manufacturing, if you look at a typical car, it has about 10,000 parts which are coming from at least 20 plus countries. Very rarely everything gets manufactured or created within a local environment. So that's a typical scenario. If you take a look at software, probably the similar scenario, we don't know, we don't even know. I'll come to that part. At a global supply chain, just take a look at what is actually the supply chain mean. It is basically an ecosystem of resources that are put together to create a design, deliver, manufacture, and operate a product or service of your company. If you really look at it from that perspective, if we apply the software and cybersecurity angle to it, that supply chain now splits into the products and the things that go into will become like hardware, software, the cloud, network, storage, the people means the service providers, which can be developers, operators, could be anybody, right? Whole of these is the actual components of the supply chain. Now, this kind of a supply chain is kind of exposed to several types of risks. If we take such risks, like it can suffer from things like the natural calamities. A drought happens, no water, production gets hit. Or there was excess floods in Indonesia, supply chain of hardware like hard disks has happened, and about 3 years ago, PCs weren't able to roll out of the factories. Today, because of Ukraine war, we do not have supply chain of the components like electronic chips. And there is a geopolitical tension between Taiwan and China. Chips are in shortage, right? Something happens, in pandemic happens, workers flee, the great migration happened, textiles were under stress. Really look at it, I mean the whole, any simple thing can disturb a supply chain. And imagine that now happening to software. We call the data is the new oil and software is the new business. Actually the business is now software, no more the product what we have been selling. The software has become the business. Why? Because everything, the DNA of any business is now getting truly impacted by how the IT is driving that business, whether it is selling to procuring to, okay, end to end, A to Z operation, right? The value chain of the company is now dependent on the software now. Given that scenario, you know, this software, the hackers have recognized one thing. Where do the hackers go? Where there is money, right? Hackers were going after credit cards, hackers are going after personal data, hackers are going after financial data, going after health data. Now, they have to get maximum, I mean, they are one of the best economists essentially, with the minimum effort, maximum impact, right? With that, now imagine what happens. If you have to really get maximum value out of their effort, they have to go and shift their focus to where it hurts most. So if a well orchestrated and coordinated attack on a supply chain can result what is called as a chain reaction. Why chain reaction? It is not affecting that part. The effects are ripple. The effects are on the supply, down the value chain. And say if I have built a product like Log4J, I have used in my product and I am the target, assuming my security is good, they are not able to penetrate to me, they can come through the back door of Log4J and came in and they are inside me already. Right? This is the challenge of the supply chain. Now, if we take a look at this, you know, I'm not really focusing on the software, but the software has become the most important. And if we take a look at it on the open source, Log4j become a sort of example for open source, and this has become a component that has been used by several softwares. See, like unlike Kasaya and you know, SolarWinds, they were used to manage an operation or manage a network, manage something. So it never was part of your DNA. Whereas Log4j was one different software that was part of a DNA of the software. I mean, it became a component. So if you really look at it, you know, the component that got affected, probably it was affected due to something else. So if you take a look at that example today, there is a study somewhere, I think it was some ENISA or somebody tried this survey. Nearly 97% of the software, including closed software, will have some component of open source. May not be in the level 1, may not be in tier 2, may not be in tier 3, but somewhere down the line. Now this is the real challenge for a corporate or an organization to really look at the say supply chain security in that level. But typically what happens, most of the time we focus on the first level of supply chain. We don't even go below next level. In fact, we don't have time and effort to manage our own security. Where will you go and go after the vendor supply chain or supply chain security? So that's the second part. Now, if we go to the, sorry, I'm taking a little more time. On the supply chain of open source, if you really look at it, there are things like, you know, what is so different about open source? Open source, the code is available, happily available. That means the vulnerabilities are also available openly. Someone needs to look at the right place, right? Now, second part, the intellectual property. You know, people grossly misread and misunderstand the licensing of our supply chain, of open source. There are at least 200 types of licenses which are available, like MIT to whatever, the GPL to, yeah, there are hundreds of 200 types of licenses, which kind of certain times enable, also prevent various utilization of that software, but not using that kind of a software in the right way can kind of, you know, put in legal risk. This is not the software risk, but the legal risk, because I kind of used a product and sold something and made money out of it, which I am not supposed to, I'll get into trouble. That is another type of risk. Then security. Who is accountable for security in any open source? Everybody, right? Everybody is equal to nobody in the real world. Everybody is equal to nobody. Can be anybody, but nobody. That's how it works. So when there is no accountability for anybody within the team or the contributors for security. So that means Anybody can integrate any component into it and can generate a branch or a release. So that means we are done. These are the kind of challenges which will come into the open source. Now we can cover more topics, but these are giving sufficient feed for rest of our tasks talk.
Sure. Thanks, Mr. Gupta, for the very insightful talk on what an open source and how it can affect the supply chain. So I think from what Mr. Gupta said, we could clearly say that it's not just the open source which has any vulnerability. Even a closed software can have any vulnerability, and that definitely can have the risk in the supply chain, right? And in the recent times, we are talking about supply chain. Log4j is one thing which is being prominently discussed, but we are forgetting that this is not the first instance of a supply chain risk. We have seen many previous ones, and the first one, if you can remember, it was OpenSSL, Heartbleed, that was discovered in 2014. But because of the penetration of the internet being very low at that point of time, it did not become such a big news, though it had a very great impact. Now, coming back to the present scenario, which everybody is talking about, Log4j, my next question is to Minatee, to find out what exactly was the issue with the Log4j and why was it creating so much of noise or news, I could say.
Thank you, Sunil. Good afternoon. So, Log4j, as you know, is a logging library. Thank you. So, Log4j is a logging library of Java, very prominently used across most of the Java applications. Okay, so even for that matter, the error screen that you see when you reach to an unreachable website, 404 not reachable, is a Log4j message. Okay. So it's a simple logging utility, very much prevalent. Now, that by itself is not an issue. The issue is somewhere down the line, while developing the Log4j component, there was an addition of a feature which basically enables execution of code. And the intent was the logging utility should be able to fetch dynamic data from the server. For example, if I'm a logging utility, I should be able to say maybe get the IP address of the database server and show it in my logs. For that, they introduced a component which can dynamically get that information. And as in Java, many of these are objects which can be executed, and that is where the issue is. So we have an utility which enables execution of code. And this was there for about 7-8 years in the library till it was discovered. Before that, maybe it was exploited, we don't know. But in 2021 December, it was declared as an open source, a known vulnerability. And the reason why it became so important is, of course, number one, it's very much popular, almost used in all, many components. Second one is the ease of exploitability of this is very easy because you do not need an authenticated user to exploit this vulnerability. That's the reason out of all the vulnerabilities of Log4j, one of the vulnerabilities had got a CV rating of 10. That is, highest risk. Okay, this is the second reason why it is so important. The third one is because the impact is so high, almost every component is affected. But the issue is, as software industry, we are not that mature to understand what are our components that we embed in our software. Only if we know that we have this component, we can patch it. But that kind of maturity is still growing. And the fact that by the nature of the software, a Log4j component could be there in your software, but it might be in some depth, say for example, level 3, level 4, level 5, and so on. So detecting it is also difficult. So all these together make this issue very important. And this is just one of the issues. We are going to see so many more going ahead.
I would like
Thanks,
to
Ms.
add.
Minatee.
See, just not the logging was much easier, but why did developers adopt Log4j? Because if you have to write the same code for doing logging, and for various types of instrumentation, it was much more difficult to write by yourself. So Log4j kind of simplified that whole process of using. So that became popular. It was one of the most popular because it has merely simplified the logging mechanism and became much more easier to use. One simple thing. Part one. Like the impact was good, right? Because every software, every application was used. But it's not, the problem didn't stop there. The problem persisted because when the patch was released for Log4j, it did not completely fix the problem. I think it was the CVID 224488 as the first version, first number that came out, and that didn't really fix. So the Log4j, and it took almost, I don't recall, I think 31 days or something to release the first patch itself. After that, the second patch was released. Then third patch was released to fix. Then the fourth patch. See, if you really look at it from a production server perspective, if I'm running as a production software, which has a component, Log4j has this. Now I have to take downtime, plan that my upgrade, test it before. The amount of effort required on an operational front was very, very high. Now a patch was not complete. I mean, well, from the developer perspective, because it was some kind of rush. Now the amount impact is too high, so somebody put together, because it's again a community of developers, they fixed something and gave it. But the fix was not complete. It still left some more vulnerabilities. So that is one of the major challenge that Log4j posed, because we had to now actually take 4 times downtime for the same application. So it made thought process even longer for us to adopt anything like that.
Sure. Thanks, Mr. Gupta, for that, and Minatee for the introduction on what this Log4j was. I'll move on to Ms. Dhanalakshmi in the same topic to understand from her perspective what was the issue and why did it create news. From you represent the threat intel industry, so I would like to understand from your perspective what your views are on this.
Yes, thanks. As Gupta said, right, this particular Log4j, also known as Log4 shell vulnerability, which was having it's a popular tool which is used for Java-based logging systems. And the vulnerability which was notified during the end of December 2021 was more of like RCE, remote code execution vulnerability, which can allow the remote code execution without authentication. So with that said, I'll talk about the operational challenges, how the operational challenges has been created because of Log4j. Basically, this, as per the research study, Log4j is not only used directly. This particular Log4j vulnerability is Log4j library is used as a software bundles, as the third layer or fourth layer, as well as directly also used. As per the research study, 60% of the Log4j libraries were used indirectly, wherein only 40% is used directly. With that said, it creates an operational challenges to the security operators to identify and narrow down how this Log4j library is used inside their enterprise softwares and systems. Secondly, based on how they are utilizing this Log4j vulnerability in their environment, they have to identify the different way of patching methods. As he rightly said, there are multiple patches came in, but even then, because of the diversity nature of the usability of the Log4j vulnerability, it is difficult to the organizations to come up with one solution, go ahead with patching using that one-step solution. That's where industries and organizations faces a lot of trouble to fix this vulnerability. Sometimes it might have been like achieved based on their usability within a day's time, or sometimes it will take more than a week as well. Lastly, particular this Log4j vulnerability is also part of supply chain. We never know where our vendors are using this kind of open source libraries. So that makes a little more complication. That's why when the Log4j attack started, security industries evidence the attacks not only to IT sectors, it also like spread across healthcare, finance, as well as even OT sector. Operational technologies were impacted. Moreover, the actors was focusing on to like not only the financial motive actors targeting this Log4j, so considering the critical infrastructures also under target, even nation state sponsored attacks was happened due to Log4j.
Thanks, Ms. Dhanalakshmi, for that. So we are realizing that there are a lot of issues in open source software. Now, question pops up: should we really use open source software, or should we go with the closed source software? So let's hear from Minatee what she has to say on this topic.
So open source software usage is now a given. I think there's no going back on that. And its prevalence has increased, and it will exponentially increase going ahead. And the reason is it really enables any development team to develop with speed. If you see Uber, Facebook, Google, they are all they have actually thrived using open source. And not to mention the many startup companies who actually reuse the code, and it gives them the speed, financial benefit, and so on. So open source software is here and is there to stay strong, that too. The only thing that we as an industry have to ensure that the open source community gets the right kind of support to develop and focus on the software being developed. So till now, largely it has been voluntary contributions from enthusiasts to code. And there are concerted efforts in enabling these open source community to make them stronger. So for example, Microsoft, which was about 20 years back a strong proponent of closed softwares, is now a very strong proponent of open source software. And in fact, they are one of the major contributors along with Google. So in summary, I think things are changing for better with a community around building more secure, focus on building secure open source software, already doing the rounds with major companies contributing to it.
Sure, thanks Minatee. That means open source software is going to stay. So what can organization do? They only have to be prepared to avoid issues like Log4j happening. So let's hear from Mr. Lokesh on how organization can be prepared to tackle some of these issues.
Sure, I think we all understand the significance of the problem now, right? So to put it in perspective, let's see some of the statistics, right? If you go into GitHub and see the number of open source packages, you can very much see that it is almost beating Moore's law. That means 3.8 million lines of code and exceeding, and it's doubling every couple of years. That's the magnitude of open source code we are talking about. If you look at the other equivalent statistics, right? If you go to NVD database, the National Vulnerability Database, 18,000 and plus CVEs are assigned to the open source packages. That's an alarming number. And if you put that in perspective compared with closed source, right? It's almost 1/3 to 1/4 of the total number of CVEs we see. So what this all indicate is we need to be extremely cautious. We need to have practices starting from the beginning of the software development cycle in order to mitigate and remediate the challenge here. So we can keep going on talking about this, but it is important to take a prescriptive and systematic approach in handling this. Probably we'll try to summarize this in a 5-step process here so that everybody can take home some key insights from this entire discussion. So when it comes to the handling third-party code, which equally applies to the commercial off-the-shelf like your free open source, number one is about selecting the packages. How can we tell our developers, architects, technologists today, hey, these are the good ones, these are the bad ones, or these are the ones that are having some flags of risk? So few indicators here. You can either go to the NVD database, look at the number of vulnerabilities reported on the popular packages, look at the development support, number of developers involved in that package, how actively they are contributing to that, what is the cadence of the fix or the patch being issued, how frequently they are maintaining and rotating the developers, how transparently they are publishing metrics about the development process of that open source. Without factoring all these things, if you go ahead and select some packages, it's quite possible that we'll run into trouble similar to what happened in many popular projects. The second thing is, how do you maintain it? When we say maintain, the most important thing is keeping an inventory. We talked enough, including the previous panel, briefly touched upon the bill of materials, very specifically the software bill of materials. What this means is we should have a very comprehensive and thorough inventory of all the packages, open source packages used in a given solution or a given offer. There are a lot of solutions available to create this. It needs to become an industry mandate, both to consume the open source software as well as to distribute the open source software to have an SBOM. SBOM is more like a README file or a document that comes along with your software package. There are a lot of formats, industry formats. For example, one such format is SPDX, Software Package Data Exchange. There is also open source formats like OASP, Cyclone DX. All these formats helps organizations to communicate the inventory and also helps other organizations to consume this inventory. Once you have the inventory, when events such as, let's say, Log4J happens, it becomes easy to identify the vulnerable assets. Starting from Heartbleed that Sunil mentioned, and all the way up to Poodle and variety of other attacks we have seen, all the way up to Log4j, the major problem with all large-scale organizations is the lack of such an inventory. So without an inventory, we cannot do anything about it. You cannot protect what you cannot see. Visibility is the biggest problem, whether it is about threat intel and hunting, or whether it is about vulnerability management and remediation, you need to have visibility to the packages you're using. That's number 2. And number 3 is continuously assessing for security. Of course, we have variety of tools, manual, automated, whether it is static analysis, dynamic analysis, runtime analysis, or even penetration testing, red teaming exercises. While these are all good, when it comes to software, open source software security, the most important piece is what we call as SCA, or software composition analysis. Basically, you need to know what are the dependencies of the packages you're using. There are 2 types of dependencies we need to be very careful. One is direct dependency, another is transient dependency. Transient dependency in another way is dependency on dependencies, right? So when you don't have insights on these dependencies and you don't use software composition analysis, it is very difficult to automatically or semi-automatically manage this space. And the 4th step is about mitigating and accepting the risk. Of course, there are standard risk management processes. What we use for our proprietary code can very much be extended, but we need to add newer dimensions. When you source a software from open source, whether it is GitHub or other locations, we need to do more factors than what you typically analyze using your closed source. For example, if you talk about commercial off-the-shelf third-party software, you look at the vendor. What is the maturity of the vendor? What are the best practices that they follow? Can we extend similar practices to GitHub-based projects? Probably not, right? That's where a lot of organizations are depending on peer reviews, and this SBOM is going to really help in that space. And the final one is about making this as a continuous process, because it is not like one-time instance and forget it and move on. For example, if you take the example of Log4j, we had 5 different CVEs in a span of 4 to 6 weeks. That means it is not about one CVE that the organization patches and move on, right? They had to handle this over a period of 4 to 6 weeks in order to completely come out of this. And also, we need to ensure that our incident management and incident response teams listen to this and then continuously complement that with the CSET process. So basically, when it comes to response, continuous monitoring and response, there are 2 pieces. One is CSET, the Computer Emergency Response Team, which has to monitor issues, whether it could be threat actors exploiting these vulnerabilities and then patch and then act on them, during it, which falls under your NIST detect and respond team. Similarly, your product security incident response team, also known as PSET, they need to be able to find these vulnerabilities and issue patches to the products and applications, right? So this 5-step process covers or gives a comprehensive approach to how small, medium, and large-scale organizations can really handle this space. Maybe I'll take a pause to see if there are any questions, and then we'll deal that.
Sure. Thanks, Mr. Lokesh. So basically you're saying security hygiene is very, very important in handling this. So let's hear from Ms. Dhanalakshmi on from an industry perspective, what tools are available to help an organization to overcome this or support this.
Thanks, Sunil. So as we see, like kind of like utilization of open source softwares, as well as like increasing attack surface and using the different type of digital transformations. So each and every organization has to continuously monitor their attack surface, and they should use the tool something which can help them continuous monitoring of attack surface, which is called ASM tools. And in case of these kind of zero-day attacks and the exploitation attempts, threat intel plays a vital role there, especially dark web intelligence that would help to identify unknowns. Here what I mean unknown is like 0 days, which cannot be known to the software vendors or authors or system providers. So in that case, they have to have a continuous monitoring of the threat landscapes, including threats, 0 days, vulnerabilities, etc., through a surface as well as the dark web intelligence. And apart from that, my organization should implement zero trust architecture. What does I mean here is, zero trust architecture is a well-known term recently used across all the cybersecurity industries, wherein in this case of like Log4J, say for example, if the attacker can able to like exploit the front-facing server, but they can also try to do the lateral movement. If the organizations have a proper network segmentation, which can allow, which can stop, prevent the lateral movement of the attackers inside the network. That way they can reduce the impact of these kind of zero-day attacks. And then since the Log4j is also like as part of supply chain, so organizations should have a proper and better supply chain risk management using the periodical third-party risk scoring monitoring and providing this, educating them as well. And apart from that, the generic procedures, something like following the implementing multi-factor authentication and educating the employees to use strong password and implementing strong password policy is also important.
Thanks, Ms. Dhanalakshmi. So that means from a software side, hygiene needs to be maintained in a SDLC process. From an operational perspective, ensure that your incident response is up to date with the proper threat intels so that an organization can be aware and be prepared whenever this kind of thing happens. Let's hear from Minatee if there are any regulations that help an organization to drive this.
From a regulations perspective, a lot of things have happened in the last 1.5 years. To start off with, in March last year, there was a US presidential order asking that all vendors selling software to US federal agencies need to submit their software bill of materials as well. Okay, and everybody in the industry also understands that software as an industry is still maturing in terms of the kind of preciseness which is there in the hardware or manufacturing industry is not there in the software industry yet. So in the regulations and the guidelines following it, it is clearly envisioned that this maturity is a journey, but they have clearly stated as to what is the minimum set of requirements that needs to be created for a software bill of material. Okay, and they do envision that this will grow, and there are some advanced bill of material elements that needs to be added. But that has already come into force in May 2022, wherein anybody selling to the US federal agency needs to submit the software bill of material. That's number one. The second thing is, so Philips is primarily into healthcare, and for healthcare equipments to get into the US market, we have to get a FDA clearance. Okay. Now, FDA also has a draft guideline clearly mentioning the need of a SBOM. And it's not only the SBOM that they are asking, they're also asking for the vulnerabilities associated with those components. And they also very clearly understand that though the SBOM for a particular software, a particular version of the software could be a static information, but the vulnerability information is a dynamic one because of the threat landscape or the vulnerability landscape. So they do expect whenever there is a new vulnerability, the vulnerability information is updated and also accessible to the customers. Similarly, we have regulations in China already into effect from March this year, which is asking vendors to submit their software bill of material. And the minimum elements is similar to what is being asked by the US government also. We also have a consortium of regulators from many countries across the world. It includes Australia, it includes EU, Canada, Japan, and so many countries, and that consortium is called IMDRF, which also has released a draft guidelines saying the need of SBOM. And when we say SBOM, it is not only SBOM that they're looking at. Most of the regulations are asking for related vulnerabilities along with the SBOM to be submitted. And very clearly, if I see the healthcare use case, the ask is, we, as in a, say, a pharma industry or a medicine industry, we write the list of ingredients. Similarly, every software will have its SBOM attached with it. Along with it, it will make transparent the vulnerabilities to the end customers. So I, as a manufacturer of, say, healthcare device, will submit my SBOM, and also the end goal is I should be able to notify the customers if there is a new vulnerability so that the customers are able to take some first aid actions before the manufacturer gives a patch on the device.
Thanks, Minatee. So it's not just about an industry coming together, but even regulators are putting forward their own rules and regulations, making sure the software industry follows certain guidelines or some best practices to ensure the supply chain risk is minimized. So I'll hand it over to Lokesh for his closing or just to close off on this particular topic.
Sure. Thanks, Sunil, and thanks, everyone. I believe we clearly understood the problem, and we also see how to navigate this space, both from incident response, software secure development lifecycle, as well as from the associated regulatory guidelines and the supply chain security in general. So when you put all these things together, the next logical question we may have is, hey, there is so much of software out there, and we are all consuming left, right, center. What is that as an industry we can do, or what is that industry is already doing that we can leverage? So I just want to call out a couple of things. One of them is the Open SSF project, or the Open Secure Software Foundation. A lot of organizations starting from Microsoft, Google are contributing to that millions of dollars. And their objective is to pick up the most popular open source projects and then build them and secure them. For example, very recently they have launched what they called as Alpha Omega project. When we say alpha, they are going to pick up some high profile, widely used software packages and then fund the developers who are contributing that, so that we have monetary incentives to such projects, so that they don't run into vulnerabilities like what we had seen in the OpenSSL or what we have seen in the other related packages. And there is also the widely followed OASP project, which has called dependency checkers and dependency trackers. Those who are not really able to afford to buy a commercial tools to use this, it is important that they embrace such tools so that they do not contribute to open source security risk and then play a vital role when they really check in their codes into GitHub and let other people develop. In addition, all the package managers associated with major software libraries are bringing in their own checks and balances so that nobody can do any type of attacks such as domain confusion or type squatting, which are more prominent in open source type of packages. So to conclude, I believe it is very important to realize this is a collective effort and no single individual or organization or entity can solve this problem together alone. So we have to come together to really face this together.
Thanks, Lokesh. So the industry is actually doing certain things to ensure this software supply chain risk is mitigated. I want to conclude this session by saying that open source software is going to stay, supply chain software risk is going to stay. It's up to the organizations to see how they can be prepared to handle any crisis that comes forward. I thank all the panel members here, and I'll open the floor for any questions if they have. The monitor already shows the time's up, but probably we can take a question or so. Anybody has any questions?
Good evening, everyone. So I have a question on the same lines on Log4j vulnerability, right? You mentioned about 3 to 4 different CVCs got released in within 1 month or so. So does it the end of it, or do we still have one more attack surface area coming out from Log4j? I just want to take your opinion.
See, as far as I understand, after those four, it was fixed. But you never know what else is there. Okay. Fundamental rule in software bug fixing is every bug fixed creates a new bug until you find it.
So if I can just add to that, we never know how many new more variants of COVID is waiting, right? I think a similar scenario applies here as well.
You are loud enough. Come on.
I'm not coding for my organization. Okay. So if I'm contributing for myself, means I'm doing for one of the tech, I'm creating a kind of a code for myself from my end, and I'm using something called build tool from like Maven or Gradle. So I'm going to the internet and I'm searching for for Spring framework or Logstack or Log4j. This is the most used jars or most used dependencies, and I'm just putting it out. How will, as an individual, I will check that this is not vulnerable. Means what kind of parameters I should go for? Because I know in organization there will be multiple layers of check before you do git check-in and commit. So it will mention that these are the vulnerabilities. But as an individual, if I'm going to do that, because for example, if I'm developing something or someone has developed something, that code might be used somewhere else. They can directly do the clone and do it. So as an individual, how can I make sure that I'm using the correct dependency?
Would you like to address it?
So it's not just about a person improving his developing skills. He also needs to improve how to code it securely. I think that is the training that everybody has to undergo, and there are a lot of free learning portals that is available for that. Unless an awareness comes in, nothing is going to change. You know, there's a saying, right? User is the weakest link in the chain. So here, developer is the weakest link in the chain. As long as he is not aware of what the security best practices are, or unless he gets trained onto that, this problem is not going to get solved, irrespective of whether it's an organization or you're working at an individual level.
Just to add there, see, it depends on what you are trying to do. Are you doing it for a commercial purpose? There's a commercial purpose involved, then you may be liable for certain actions. If the code what you're delivering, and if it is delivered with certain defects or dependencies that have vulnerabilities, your total code, your piece of work is vulnerable, right? And are you controlled by the risk? Are you controlled by that or not is the question. If you are doing it for the fun, heck yeah, I don't even care about that vulnerability in my system. If I'm doing it for open source, I don't care. Whoever is using can, this is how typically the systems, I mean the open source systems are built, right? And if you are doing for a commercial purpose, when you are, there is a money, transactions involved, then you will say there is a liability, warranty, all sorts of things come into play. I think the transaction, the nature of product what you're building, the nature of code that you're building, and the commercials that are associated with determine the level of security and so on.
Looking for software components which could have vulnerability. But as Lokesh had mentioned earlier, there are tools which are open source, which you can use to see even if you are using a very common component. You can run those tools, like you mentioned, dependency checker is one of those tools. Okay, similar tools but with a different intent is dependency tracker from OWASP itself, which will help you identify for the software, open source software, what are the vulnerabilities, what are the license risks associated with it. Right? And many of these tools also give a dimension of operational risk. So if it has not been used or nobody is updating it for a long time, it is an indication that maybe this is not going to be maintained and maybe not a good idea to use it.
Yeah, I think most of the points are covered, but the only thing I would say is look at the project. The project should be actively developed, and there should be also bug reports that are in the project. So that will give you reasonable indication in addition to running the OWASP check tools. So that are the basic checks. But I don't think beyond that, as an individual, there is only limited capacity we can do. But there are also OS intelligence tools, generally called as OSINTs, which gives you hints about whether the developer is from countries that are on embargo. So you don't need to really pick those codes that are not really vetted or developed by countries where we generally have some suspicion about malicious intent. So that's another kind of thing, but that will get into a little more involved analysis.
Most of the things is already covered. I would like to add one more point. When you are picking up this open source codes, it is along with secure code practicing, you should have to go through the source code review in terms of understanding the security flaws. That way you can ensure that your application is not a flaw for at least well-known vulnerabilities. And also, as said by the other panel members, it is better to validate the author of that code, as well as check for the NVD database for the vulnerabilities reported for that particular module, what is its severity and how it can be impacted, etc.
Thanks for that. We are closing this session. Sorry, your time is up. Thank you all for listening to us.